Hello everybody, Mingalava. Welcome back from Clitop Engineer Yoga lecture series. My name is Damien Tak. I'm doing mechanics subject lecture series. And for those of you who are watching this video for the first time, the textbook that we use is Mechanics 2 student book, and that is published by Pearson Edexcel International A Level. We are covering all the theories and most of the problems in this textbook. So at the end of this lecture series, you would be able to sit the International A Level exam. So do subscribe to our channel. And of course, for those university students, you will get strong foundation in engineering mechanics. And in this video, we will have a kind of combined motion. So you have an object, you will throw your object against the pull of the gravity. So object will freely move upwards. And now of course, when it reaches the maximum height, there will be no kinetic energy, the velocity will be zero. Then the object will fall freely back to the ground. So we are looking at this motion today, and of course, as usual, with our lecture, before we start this, let's try to look at uh, some of the important points from the previous lecture. So we have the free falling motion and freely throw upwards motion. Of course, we studied them individually. So if you look at free falling motion, the object is the object is initially at a certain height, then the object can have certain initial velocity, or if it simply drops, the initial velocity can be zero. And now, of course, the object will fall to the ground, and there will be no air resistance, and the direction of motion is vertically downward. So we take vertically downwards as positive. And since the acceleration we have proved is just a equal to g, so g is also downwards direction. So the direction of acceleration is just the same with direction of velocity. So the object is speeding up, so its motion is constant acceleration motion. And of course, for this reason, the speed will be just v squared u plus gt. So there's just the formula for finding speed in the constant acceleration. You just substitute g in place of a. Now, one thing that you should note is the object will have higher speed when it hits the ground, because of the simple reason it has traveled the longest distance or the longest time. So that's the reason higher speed will have uh, when it hits the ground. And of course, depending on the elastic property between the ground and the object can in fact bounce back. But that is not the scope of this video. We will do it, of course, in when we study impulse and collision. The next motion is freely throw upwards. If you look at freely throw upwards motion, your object is initially at a certain height. And in this case, you just have to provide initial speed or velocity, because your object is moving against the pull of the gravity. So you need to add kinetic energy. So after it gains kinetic energy, it can move up against the gravity. So the direction of motion of velocity is upward. So we take upwards direction as positive, because simply it is the direction of the motion. And now of course a will be just equals to minus g. In this case, acceleration is negative because it's going downward opposite to the direction of the motion, and that is the reason the type of motion is constant deceleration. And of course, for constant deceleration, your acceleration will be negative, and you just substitute in the speed equation for constant speed motion, and you will get v is equal to u minus gt. And looking at this equation, you can see clearly that after certain time t, your object will have zero velocity, and now of course the kinetic energy will be zero. So there's no enough energy, to move further, and the object will just fall back. So when the object velocity is zero, it will just attain its maximum height, and then it will just fall back to the ground freely. So those are the main points that we have for two different motion, free fall and freely thrown up motion. Of course, today we will look at combination on that. So let's try to look at that. Okay, now let's try to look at the combined motion. So you have your object. You will throw your object against the pull of the gravity, of course, vertically upwards. And then when it reaches the maximum height, there will be no kinetic energy. And then the particle just force freely to the ground. And we will look at that combined motion. So so the way we try to look at this problem is as a combined motion. You will find in fact a lot easier to look at like that. So if you look at that, you have your object uh, a certain initial height from h from the ground, and then at time t is equal to 0, you just release your particle against the pull of the gravity with the initial velocity u. And of course, you know this is slowing down motion, so the speed will be reduced, and then finally it will attain that zero velocity. And then when it reaches its position 2, it will just falls back to the ground. And here that's the way we do is we will have a kind of uh, uh, one part from 2 to 3 position because of the special reason later you will find out. So from position 2 to 3 it's just free falling motion, so it's constant acceleration, so the object will retain some speed, and then of course it will get some final speed when it reaches time 3, sorry, at position 3, and from 3 to 4 is again the free falling motion. So the way we try to look at this problem is a kind of 3-part motion. Let's try to look at this. So if you look at this, this is a kind of combined motion, and we will have part 1 from 1 to 2. So from 1 to 2 is of course a freely throw upwards motion, so that's very clear. And because it's decelerating, going against the pull of the gravity, the acceleration will be just minus g, and of course the speed at any time v equals to u minus gt. So your object is slowing down, so the speed will be reduced by 9.8 meter per second within every 1 second. And of course, finally, at a certain position, at position 2, you will have the velocities will be 0, your final speed will be 0. And we are interested in finding out how much the particle takes from position 1 to 2 to reach the maximum height. So at the maximum height, the final speed is just 0, so you will just substitute 0 there, and initial speed is u. And then of course, if you move gt to the left hand side of the equation, you will have gt is equal to u, and then the time taken is just u divided by g. So you can easily find how long does it take for the particle from position 1 to its maximum height. Position 2, it's just t is equal to u divided by g. So that is the way you try to find it. And of course, you can also find the value of speed at somewhere in between. So you just substitute the time t. So basically, what we try to do is you are first trying to find the time taken from position 1 to maximum height, and then this time interval will be just divided into several time interval and substitute in this equation so that you can get the velocity as a function of time. Right. So this is the first part of the motion, and of course, when the particle reaches position 2, because the speed is 0, there will be no kinetic energy to move further upwards. Then the object will just free fall because there's a potential energy, and because of the potential energy, the object will try to release some of the potential energy, so it will just force back from the maximum height to position 3. So let's call this part 2 motion from 2 to 3. And of course, if you look at part 2 motion, the velocity is downwards and acceleration is downward as well, because acceleration is just equal to g. So this means your object is accelerating motion, so it's constant acceleration, and the speed can be found by this formula: v is equal to u plus gt. And of course, you can easily see the speed is increasing because the slope is positive. So the final speed at maximum height from freely thrown upwards motion will be the initial speed at the, again, position 2 for the free falling motion. So your initial speed u will be just 0. And so you want to find the speed at position 3. So let's try to look at this. So v is equal to u plus gt. So what you do is you will substitute initial speed u, which is just in the speed at position 2, so which is just 0 plus g times t. And now, since u is 0, you have final velocity at position 3 will be just gt. So if you look at closely, we have a kind of show or proof that the final speed at position 3, which is just gt here, it just equals to the initial speed in the part 1 motion. This means, of course, that this speed here, when you start to release the particle, which is just u is equal to gt. So if you look at the magnitude of the velocity, initial velocity at the freely throw upwards motion, which is just gt, this is exactly equal to the final speed for the free falling motion from 2 to 3. So this means at position 3, the final speed of velocity is just gt, right? So you can easily see that the speed in fact at position 3, it in fact just equals to the speed at the initial release in the freely upwards motion. So yeah, of course that makes sense, because if you look at the slope is just positive g here for the increase in the free falling. For the decrease in free falling, the slope is negative g. So basically they are just the same magnitude, but just this one is slowing down, and the free falling from 2 to 3 is speeding up. So that is the reason. And again, if you look at magnitude, this one starts from u and decrease with minus g, the slope minus g, and finally the velocity is 0. But for this side from 2 to 3, initial speed is u and the slope is g, so the increase in the velocity is just g, and then at position 3, the object, of course, final speed will be just gt. And part of the reason is because it's constant acceleration, and they are, so from 1 to 2 and 2 to 3, the heights are the same. And since you neglected the air resistance, the rate or increase or decrease in the velocity or speed is just the same. So that is the reason the final speed at position 3 is just equals to the initial speed at position 1, right? So that is very clear. Now, of course, if you look at the velocity, they are not the same, because at position 1, the velocity is positive, vertically upwards. At position 3, velocity is vertically downwards. So the speed is the same, but the velocity, the direction is not necessarily the same, right? And apart from that, you can easily conclude that since the for this side from u, u is here kind of gt, and for this at position 3, v is gt. So if you look at this, for freely throw upwards motion from 1 to 2, the speed is reduced from gt to 0. Final speed there is 0. And for free falling motion from 2 to 3, initial speed is 0, the final speed is gt. So if you look at that, you can easily make sense that the time taken will be just just the same for both sides, because the height is the same, the rate of speed increase in another side is equal to the rate of speed decrease in another side. And of course, if you look at it, the two speeds at position 1 and 3 are also the same. So that is the reason they will just take the same time. So this means if you look at the time taken from 1 to 2, t1 2, it just equals to the time taken from 2 to 3. So that is the reason if you are asked to find the total time taken from position 1 to 3, so this means after you initially throw your particle upwards freely, and then if you want to find the time taken from that initial position to position 3 after the object free fall and pass the original height. So in that case, the time taken will be just the same. So you don't have to find the time taken for both sides. You just find the time taken for one side, and then you just multiply by 2, because they take the same time, right? And of course, apart from that, the final speed for the part 1 motion will be initial speed for part 2 motion. So v2 will be just equals to u2 on the other side. At position 3, I have already told you the speed at position 3 is just equals to the speed at position 1, right? Okay, so and now let's look at from 3 to 4. I will just go part 3, but if you don't want, you can have from 2 to 4 at just one part. But the reason I'm trying to split this part 3 motion is because 2 to 3 is quite kind of interesting to look at, because at position 3 the speed, the final speed will be just equals to the speed when the object is first released. So that is the reason I'm trying to split the motion from 2 to 3 and 3 to 4. So if you look at part 3 motion, again of course free falling motion, and that's the reason you can use the formula for finding v equal to u plus gt. So you can find the speed anytime t, just substitute the t is equal to here. Of course the initial speed you can be just the speed at position 3. So the final speed at position 3 can be just substituted in place of u, and then of course you are trying to find the speed as a function of time. But so let's say I want to interested to evaluate how much is the speed at position 4, but the problem is we don't have any information on how long the object takes from 3 to 4. So this means the time information we don't have any idea, in fact. So if you look at this equation, we have two unknowns. The speed we don't know, we want to find it. The time taken from 3 to 4 we don't know as well. So you have two unknowns and only one equation you cannot solve, of course, looking from the linear algebra point of view. And now what you can do, in fact, you can just find the final speed v at position 4 using the height information here. So if you know the initial height or location of the object, you can find the final speed at position 4. But in order to do that, we need to know the relationship between the two speed v and u and the height of the object, the distance between them. But for the time being, we don't have the formula. But of course, in the next video, we're trying to look at that. So we need the distance height information. If h is no, you can find the highest speed when it hits the ground. This means at position 4. Now for the time being, h is unknown and we cannot find. And of course, this we will look at in the next video, how to relate vu and the height here. But for the time being, I hope you understand this combined motion. We will just focus on from position 1 to 3, and yeah, I hope that you have already understood those kind of combined motion. And now let's just look at with some of the numerical value. Okay, now let's try to look at with one numerical problem. So if you look at the workout problem that I show on the screen, so you have a particle throw freely upwards, the air resistance coming in the collector, and the initial speed is given at 29.4 meter per second, and g can be taken as 9.8 meter per second square. And in number 1, you are asked to find the time taken for the particle to reach its maximum height. And in number 2, of course, the particle then falls freely to the ground. You have to find the time taken for the particle for its maximum height to reach back at the original height it is released. And for number 3, the total time taken for the particle. So if you look at this problem, it's just again, you have an object is freely thrown against the pull of the gravity with initial speed 29.4, and then of course it will get maximum height. The speed will be then 0 there, and it just free fall. And you are asked to find the time taken for the freely throw upwards motion and also free falling motion from 2 to 3. So this is the way we're trying to look at and understand the problem. And now let's try to see the workout. And of course, if you understand the theory that we have just discussed, the problem is in fact quite straightforward. But here we will do more than what has been asked in the problem. All right. So if you look at this problem, the initial speed when the particle is released against the pull of the gravity is 29.4 meter per second. So this means from 1 to 2 motion, initial speed is 29.4. And of course, you know, at maximum height, the speed will be just 0 there. Right. And let's try to look at this part first. So this is just freely throw upwards motion, and you are asked to find the time taken from 1 to 2. And that is very straightforward. We have just discussed the theory to find that. So the time taken from initial release against the pull of the gravity to the maximum height is just u divided by g. So u is 29.4 meter per second, g is 9.8 meter per second squared. And you do the workout and you will get the time taken in just 3 seconds. So this is the answer to number 1. Okay, but here let's try to look even further than that. So you want to find the speed at any time t between 0 and 3 seconds. And of course you will get the speed equation, which is just v is equal to u minus gt. So initial velocity u is 29.4 and the speed is the acceleration is minus 9.8. So your v will be just 29.4 minus 9.8 t, right? So that is the that is the formula to find the speed as a function of time. So if you tabulate this, you will get time t is equal to 0 is 29.4, time t is equal to 1 second 90.6. So you see the speed is reducing or is decreasing. 2 seconds 9.8, 3 seconds 0, and of course it will get the maximum height. So this is the first part of the problem. And now let's try and look at number 2. In number 2 in the problem, you are asked to find the time taken for the particle from maximum height to the position when it is initially released. So this means from 2 to 3. Again, this is the free falling motion. But if you are interested only in finding the time, you don't have to calculate, because based on the theory, you know the time taken from 2 to 3 for the free falling part is just exactly the same for the time taken from 1 to 2 freely upwards motion. So your answer will be just exactly the same. 3 seconds here, right? So this is the answer. But let's try to look again a little bit farther than that. So you want to find out the final speed when it reaches the position 3. And of course, theoretically, you know, of course, in advance, this will be just equals to the speed at the initial release. Right, but anyway, let's try to do it here. So v is equal to u plus gt. At position 2, initial speed is just 0 because it's maximum height. So 0 plus gt. And now you want to determine the speed at position 3 is just g times t, and you have already found from 2 to 3 it takes 3 seconds for the particle. So you just substitute g is equal to 9.8 and the time is 3 seconds, and you will get the speed is 29.4. And now of course if you look at it, it just agree with our theory. The speed after the particle fall back and when it passes through the initial height is v3 is equal to 29.4, which is exactly the same with the speed at the initial release. And again, of course, even though the speeds are the same, the velocity are not the same. One is vertically upwards, another is vertically downward. And now again, if you tabulate, you have the time and you have the speed. And so initially its maximum height is the speed is 0, and then it attains the speed and the slope is 9.8 meter per second within every 1 second. So the first 1 second is 9.8. The second 2 seconds you have 19.6, and after 3 seconds you will get 29.4 meter per second. So this is the way it is speeding up, right? And in number 3 you are asked to find the total time, and it's very straightforward. Again, if in the examination you don't have to do, because the time taken is just the same, so you just need to find the time taken for the freely upward motion from 1 to 2, and then you just multiply with 2. So your answer is just 6 seconds. So the object take totally 6 seconds from freely upward motion from 1 to 2, and then free falling motion from 2 to 3. The total time is just 6 seconds, right? And of course after that the object will again free fall from 3 to 4. So 3 to 4 is free falling motion, and the speed equation is u plus gt. And now if you substitute, the final velocity of 2 to 3 part will be initial velocity for 3 to 4 part. So you will have initial velocity 29.4, and of course g is 9.8. So your speed equation is v is equal to 29.4 plus 9.8 t. So again, if you look at this equation, you have two unknowns. You cannot find it in fact because you have only one equation but two unknown quantities. So one of them must be known. So normally what we do is at position 4, there is the final speed for 3 to 4 motion. We try to link the final speed v and the initial speed u with the distance between them or height h. So we were trying to look at in the next video. So we were trying to look at the relationship between the final speed and the initial speed and the distance, right? So that we will look at in the next video. But of course, after you get v, you can find the time taken from 3 to 4. But for the time being, we will just stop here and let's see go back. And of course, do revise those lessons that we have learned, and also please subscribe our channel to further study further topics, right? So with that, I just want to say goodbye.